This video is going to cover very quickly trig functions that you should be aware of prior to the next topic that's going to show up, which is vector addition. So before vector addition, we just want to make sure that you're comfortable with these trig functions. You've done them many times in math class. You'll need them a lot in physics class because so far we've been working on motion in one direction, and either it's on the horizontal axis or it's on the vertical axis. But when we have motion in both directions, when an object's moving on the horizontal axis as well as on the vertical axis, like a projectile that's being shot off the table or being shot out of a cannon, when it travels in two directions, in the x direction as well as the y direction, as it goes sideways as well as up, or sideways and as well as down, then we're going to need something called vector addition, and vectors are going to be very important because we're going to have multiple directions. And prior to that, we should be comfortable with everything that's on the board. On the board, what I've put up is a right triangle. And if this is your theta, then of course the side that's exactly opposite to it is your opposite side. And the side that's adjacent to the angle is called your adjacent side. And of course the longest side of the triangle is called your hypotenuse side. Now many people call it opposite, adjacent, and hypotenuse. Some people call it A, B, and C, or A, B, and C, whatever the case may be, as long as you can identify those sides. Now, of course, if the angle was over here, if this was the angle, then this would no longer be the adjacent side, this would become the opposite side. Because if theta was over here, then this becomes the opposite side, and this becomes the adjacent side. However, the longest side is always the hypotenuse. So what you should be comfortable with, and you should be able to do this rather quickly with your calculators, or once you start memorizing the table, sine theta is the opposite side over the hypotenuse side. So if I ever ask you to find me what is the sine of that particular angle, you're going to have to just divide the opposite side by the hypotenuse. Sine theta is equals to opposite over hypotenuse. Now this is important because in this case, this is another equation, and this has three variables: theta, opposite, and hypotenuse. And you may be given two of the variables, and you may be asked to find the third one. So for example, if you know what theta is, maybe it's a 30-degree angle, you do sine of 30, and that will give you this side of the equation. And if you know the hypotenuse side, well, you've got that variable. And if you were trying to find the opposite side, then the hypotenuse side, you multiply it to the other side to multiply it with sine theta, and that would give you your opposite side. So once again, it's an equation with three variables, and hopefully you'll have two of the variables so you can find the third one. You should also be comfortable with cosine theta. Cosine theta is equals to adjacent over hypotenuse. So once again, if I give you an angle that's 30 degrees, and you know the hypotenuse side, and I'm asking you to find the adjacent side, well, cosine 30 degrees, if the angle is 30 degrees, and then you're going to multiply it with the height. Sorry, not with the height. You're going to multiply with the hypotenuse, and that's how you're going to get the adjacent side. And this over here is tangent theta. Tangent theta is equals to opposite over adjacent. Once again, three variables. If you know two of them, you can solve for the third variable. Remember, in your calculator, you should always be in degrees, because we're not working with radians. Unless I give you an angle, and I give the angle to you in radians, then your calculator should be in radians. However, if I give the angle in degrees, then your calculator should be in degrees. Now, you should also know the inverse functions. The inverse functions are used to find the angle itself. So for example, let's say you knew two of the sides, or you know all three of the sides. You know how long the adjacent side is, the opposite side, and the hypotenuse side is. And I'm asking you to find me what the angle is. Well, then you're going to have to do inverse sine. Opposite over hypotenuse gives you the angle, because sine is opposite over hypotenuse. So if you do inverse sine of the opposite side divided by the hypotenuse side, and you do that on your calculator, it's going to give you your angle. Or your other option is inverse cosine. Inverse cosine is adjacent over hypotenuse. So if you do inverse cosine of this side divided by this side, you're going to get your angle. And finally, inverse tangent of opposite over adjacent. So if you have the opposite side and you have the adjacent side, you can do inverse tangent of opposite over adjacent, and you divide the opposite side by the adjacent side, and you do inverse tangent on your calculator. That's also going to give you the angle. So you have three different ways to do it. Now, if you have all three sides, then it doesn't make a difference which way you use. However, if you have two sides, for example, if you have the opposite and the adjacent side, you know the lengths of those two sides, then of course inverse tangent will work to get your theta, because inverse tangent requires you to know the opposite and the adjacent side. Just like if you have the adjacent and the hypotenuse sides, and they ask you to find the angle, then inverse cosine will do the trick, because inverse cosine requires you to know the adjacent and the hypotenuse side, so on and so forth. So I want you to definitely be comfortable with these. You've used it before in geometry, and then again in trig, and hopefully in math analysis. So if you have any questions, we're going to definitely review some of these concepts again in class. I'll actually give you some numbers associated with the actual triangles, but you should be comfortable with these three equations, have them somewhere locked up in your memory banks, as well as these ones. These are used in class quite a bit, and so are the ones, the inverse trig function.